Let's talk about counting in bases 2 and 16. Before we get started, be aware that this lesson follows the one about counting in base 10 and base 8. If you haven't seen that one yet, I suggest you do that first and then come back to this one. Now that you have an understanding of how to count in base 10, also called decimal, and base 8, called octal, let's expand this idea further and discuss two more bases that are often used in computer science, base 2, called binary, and base 16, called hexadecimal. We'll start with base 2. Why is it called base 2? You probably know by now. It is because there are only two counting digits, 0 and 1. This idea is commonly symbolized in several ways. A flag that is up or down, a light switch that is on or off, or a condition that is true or false, often called Boolean. In digital electronics, there are two discrete voltages that rule the roost in all devices, almost 0 volts, a signal that is detectable but just barely, and approximately 5 volts. These two voltage levels are also represented by 0 and 1, with millions of possible combinations representing signals, data, processes, decisions, and the like. It is very important for any computer scientist to have a fundamental understanding of base 2, also known as binary. After all, as the old saying goes, there are two kinds of people in the world, those who understand binary and those who don't. To count in binary is simple. Start with 0, then 1, and that's it. Then you start with combinations. As you recall, the first two-digit combination is 10. Same here. Then comes 11. Now we've run out of two-digit combos, we need to do three-digit patterns. The first three-digit pattern in any base is 100, and it always follows the last two-digit combination. Think about it. In base 10, the last two-digit combination is 99, which is followed by 100. In base 8, the last two-digit combination is 77, which is then followed by 100. The same holds true for base 2, or any other base you consider. After 100 is 101, then 110, then 111, and then you move on to four-digit combinations. Here is a complete sequence that takes you through the first 17 values of base 2. Look carefully at the pattern. In the rightmost column, the ones column of any base, see how the values are alternating every time? First 0, then 1, then 0 again, then 1, and so on. Now look at the twos column. What pattern do you see there? If you noticed that the alternating pattern repeats every two values, you are correct. 0, 0, then 1, 1, then 0, 0, 1, 1, and so on. Now look at the next column, the fours place. How about that? If you see the pattern repeats every four values, again, you are correct. The values in the 8 columns repeats every 8 values, with 8 zeros first, then 8 ones, then 8 zeros, and so on. And there you have the base 2, or the binary counting system. Now, what about base 16, also called hexadecimal? How many counting digits are in that base? That's easy. There are 16. Let's look at them. The first 10 are the same as base 10, the values 0 through 9, as you can see in this sequence. Now what? We've only used 10 digits. We need 6 more. How about using symbols from an already well-known ordered system, like the alphabet? That may seem weird at first, but it makes sense if you think about it. The letter A represents 10, B 11, and so on. A good way that always worked for my students was to hold up a fist for A and think 10 for a closed fist, B for one finger up, which would be 11, C for 12, all the way to F for all 5 fingers to symbolize 15. To this day, I have to do this from time to time to remember my letters in hexadecimal. Once you reach F, the final counting digit in base 16, the next combination is, you guessed it, 10 base 16. Then 11, 12, and so on to 1A, 1B, 1C, 1D, 1E, and finally 1F. Once you get to 1F, then you start with 20, 21, 22, and so forth. Here is a table that shows all of these values. Now you understand binary, base 2, and hexadecimal, base 16. In summary, no matter the base, the pattern is predictable. Always start with 0, use as many counting digits as you have, then start the 2-digit patterns, then 3 digits, and so on. You should be able to see a pattern in a base and continue the pattern for several digits, showing a level of understanding by doing so.